take a look at combinations. When you count the number of possible permutations of a set of elements, order is important. As a final topic in this section, we're going to look at where order is not important. So such subsets are called combinations of n elements taken r at a time. For example, the combination ABC and BAC are the same because both sets contain the same 3 elements, and the order in which the elements are listed is not important. So you only count one of the 2 sets. So another example of how a combination occurs is in a card game in which players are free to reorder the cards after they have been dealt. So in how many different ways can 3 letters be chosen from the letters A, B, C, D, and E? The order of the 3 letters is not important. And so we're looking at combinations. So let's just list it out first of all. So we can have A, B, C. You can have A, B, D, A, B, E. And then you can have A, C, D, A, C, E. And then you can have A, D, E. And then we can say B, C, D, B, C, E. And then we can have C, D, and E. And one more, we could have B, D, and E as well. So we have 6, 7, 8, 9, 10 different ways that the letters can be chosen. So try out this example here. And how many different ways can 2 letters be chosen from the letters A, B, C, D, E, F, and G? The order of the 2 letters is not important. So if you listed it out, you would find that there are 21 ways. So combinations of n elements taken r at a time, we can use this formula, n choose r. So n factorial over n minus r factorial over r factorial. So it's very similar to the n permutation formula, and then you just divide by another r. So let's try to use that for this example. So we have 7 letters total, and we're choosing 2 out of them. So that's 7 factorial over 7 minus 2 factorial times 2 factorial. And you notice that we get the same exact answer. So let's use that. Counting card hands. A standard poker hand consists of 5 cards dealt from a deck of 52. How many different poker hands are possible? Order is not important. So we think that, we know we have 52 cards and they're choosing 5. So this is going to be, with the formula, 52 factorial over 52 minus 5 factorial times 5 factorial, right? So n choose r, that is n factorial over n minus r factorial times r factorial. So then 52 minus 5 is 47. So 52, 51, 50, 49, 48, 47 factorial over 47 factorial times 5 times 4 times 3 times 2 times 1. And so you're multiplying this all together. And so when you do that with your calculator, you will find you have 2,598,960 5-card poker hands that are possible. Try this example letter B. So in a 3-card poker game, a hand consists of 3 cards dealt from a deck of 52. How many different 3-card poker hands are possible? So trying this out, there's 52 and you're choosing 3 from that 52. So it's 52 factorial over 52 minus 3 factorial times 3 factorial. And you'd find there are 22,100 3-card poker hands. Now let's look at forming a team. You are forming a 12-member swim team from 10 girls and 5 boys. So the team must consist of 5 girls and 7 boys. How many different 12-member teams are possible? So with the girls, first of all, so there are 10 girls, and they must have 5 of them. And then times the boys, there are 15 boys, and you have to choose 7 of them. So then you just do, using the formula for these combinations. So 10 factorial over 10 minus 5 factorial times 5 factorial times 15 factorial over 15 minus 7 factorial times 7 factorial. And then, you spread it, write it all out. If you know how to do it in your calculator, that is awesome too. on the TI-30X2S. If you press, for example, if you're trying to do this in the calculator, you type in 10 first, then you press the button PRB, which is probability, and then you arrow over to the NCR. You'll see NCR, so arrow over to that, then press enter, and then you type in 5. And then you could press equals at that point, or you can multiply it to the 15, choose 7. So when you do that, you will find that it's 1,621,620 12-member swim teams possible. So try this example here. In example 10, the team must consist of 6 boys and 6 girls instead. So how many different 12-member teams are possible? So for the girls, it's 10. You're choosing 6 times 15, choosing 6 of the boys. And so you would find that there would be 1,051,050 teams possible.